Hello students, perhaps one more video will suffice. And let's talk about some 5.3 problems. Let's see, I required 12 to 15, which means how many problems? 4 problems? Yeah, okay, 4 problems I required, which means I have some to spare. So let's go with 5.3. Number, let me see, which one is appropriate? Let's go with number 15. Okay, how does it look? T squared y double prime minus 4t y prime plus 6y is equal to 0. And we have initial conditions. y0 is equal to 1. Y prime of 0 is equal to negative 1. Okay, let's go ahead. And please note that this is Cauchy-Euler equation. And what method do you prefer to use? My preference, oops, what did I do? Excuse me, let me rewrite again. My preference is to do this. Y of t is equal to t to the mth power. Just make this wild guess, educated guess rather, and just plug those in. That's a derivative. That's the second derivative. And then we're going to put those into this. Okay, let's go ahead. T squared times the second derivative, this one, four t times the first derivative, plus 6 times the original function, t to the mth power, is equal to 0. That's what we got. And let's do some work. Let's see. Let's move those t squared inside and this t inside. So multiply by t squared, I get just mth power here. And move this t inside, then I'm going to get just m power here. Let's move 4 in there as well. And then, okay, that's already all set. And now t to the mth power is common to everything. So I can just divide those out. Excuse me, I take it back. If it is always non-zero, I could do that, but t to the mth power may turn out to be 0, so I'd better not do that. So, okay, divide it out. Divide this one out. Okay, so what do we have? Either t to the mth power is 0, so t is 0 constantly, or this one is equal to 0. This one sometimes characteristic equation, but our textbook author calls it indicative equation, something different. It doesn't matter which it is called, let's just work it out. So this is m squared minus m, and then we have all those. Okay, all right. Let's work it out a little bit further. M squared minus 5m plus 6 is equal to 0. Okay, almost there. This one is m minus 6, m plus 1. Did I factor correctly? So we have this final conclusion here. This conclusion here, not the final conclusion. T is constantly equal to 0, which will give me trivial solution, or m is equal to 6 or m equals to -1. So this is a trivial solution, which is always the case. Otherwise, I'm going to get these two special cases. T is constantly equal to 0 or excuse me, what am I talking about? T to the mth power. T to the mth power, this is T to the mth power. It's equivalent to T is constantly 0, but in this case it means a little bit more than that. T to the mth power is constantly 0. So T to the mth power, what's T to the mth power? That's y. So I want y of t is constantly 0, or y of t is t to the mth power, but that's 6, so that's 6 power. Sorry about all those typings. Okay, we got that, and let's name it as y1, and let's name it as y2. And these are solutions of homogeneous equation. Are they linearly independent? I'll check that's checking to you, and you can clearly see they are not linear. So they are linearly independent. Take the ratio, and that's not a constant. You can clearly see that. If you want Wronskian computation, go ahead. And I don't prefer Wronskian, but there are people who require Wronskian. Okay, and then let's go ahead with the final solution here. Y of t is equal to C1. Oops, what did I do here? Sorry about that. C1 t to the 6th power plus C2 t to the -1st power is the solution, the general solution. Constantly 0. So that's a trivial solution, which is not really important. This one is important, and that too is important. Okay, we got homogeneous part. We got the homogeneous part done. Excuse me, we got the general solution done, excuse me. And then we have to consider initial condition. By the way, one more comment here. I'm having some problem here. I hope this Mathematica doesn't break off. Can I even stop this recording? Okay, let's go to part 2 of the solution. And what did you get thus far? We got these. Okay, we got that. And then we have to check these. Okay, looks like y0 is equal to 1, so this part is clearly out of consideration. Constantly 0, that violates this condition, that condition too, so looks like this is out of consideration. Out. Okay, we can move on. And then here, C1, and then plug in 0. So excuse me, what am I getting? 0 to the 6th power, 0 to the negative first power? This doesn't make any sense. And let me see. Did I make some mistakes somewhere here? Yes, I did make some mistake here. Right here, I factored in correctly. -2, -3. So m is either 2 or +3. So we have second power or the third power, not negative power. So okay, this is second power, that's the third power. And then trivial solution is out of consideration due to the IC, alright? So that's second power, that's the third power, okay. And then if I plug in y0 is equal t equal to 0, then I'm still not getting a good answer here. Y of 0 has to be 0 squared. We have to get 0, but the problem says y of 0 is equal to 1, and how is this possible? Am I missing something? Or is this problem designed to be like this? So I did everything right. Mathematica found the same answer I did. So we have t squared times the first coordinate, first constant, t cubed times the second component here. So yes, this is the same as Mathematica's answer using dsolve command. And if I plug into this initial condition, I'm not getting anything. Plug in y equal to 0, t equal to 0, then I'm supposed to get 0 squared, which is 0. 0 cubed, that's still 0. But I cannot get y0 equals to 1. Did I copy the problem correctly? And I did. I'm looking at the problem. Which means the answer to this problem is there's no solution. And I don't know whether this was intentional by the author or it was by mistake, but that's the way it turned out. No solution. I'm glad that I ended up doing this problem here. Otherwise, I wouldn't have caught this. I wouldn't have caught this, and maybe a lot of students may be just sweating out in this problem even now. So, okay. I don't know whether it was intended as a trick question or it was by accident, and considering the way our textbook author have been writing problems, I think this may very well have been intentional. He wrote all kind of possible problems, and hey, why not? No solution problem. So I think it is intentional, but still, it gives me some sour taste in my mouth. Anyway, there goes the problem set.